This is problem F6-9 um, from your textbook. And in this problem, you're asked to find the forces in members KJ, KD, and CD. Um, so I've written that down in the find here, and I'm going to highlight them. So KJ, KD, and CD. So first what we want to do is we want to just come up with our approach for the problem. So we could do method of joints, and if we did that, we'd need to find reaction forces at either A or G, and then we would just need to go joint by joint. So if we started at A, we'd do joint A, and then joint B, um, and then joint L. And I'm just doing it so that we have only two unknowns. Then joint C, then we could do joint K, and then I think we would have everything. So that would be a lot of steps. If we do method of sections, we see we can just draw a line through here. So we could cut it here. We would still need to find the reaction forces at either A or G. It wouldn't really matter too much which one. And then we could take either the right-hand side or the left-hand side of the structure. So let's do that. So like I said, we'll have to start out by doing the reaction forces. Maybe we'll just do the left-hand side. Just to be consistent, or just to pick a side. I'm just copying and pasting here. And then I'm going to remove each of those reactions and put forces there. So we have a pin at A, so we're going to have an AY and an AX. Then we have that roller at G, so NG, just a normal force at G. And we said we're going to do the left-hand side. So we just need to find those forces at A. So we can sum the moments about G equal to 0. And we'll do out of the pages being positive. So we have some moments about G. So if we go down to the force at 40 kilonewtons, and that'll be a positive force, so times 6 meters, or positive moment because it's coming out of the board with the right-hand rule, plus 30 kilonewtons times 8 meters, plus 20 kilonewtons times 10 meters, minus that AY times 12 meters. And then AX is in line with G, so it doesn't create a moment. So 2, 4, 6, 8, 10, 12. I'm just making sure I have those right. And yeah, so that equals 0. So now we can calculate that out. Okay, so we get 240 plus 240 plus 200, so 680 divided by 12. We get AY equals 56.7 kilonewtons. And we can also sum the forces in the x direction equal to 0, and that's going to equal AX. So AX is just going to equal 0. I'll box those because we'll need those. So now we can draw the free body diagram just to the right side, or the left side of the figure. I'm going to put that down here. Doesn't quite work completely, but I'll clean this up now. So we have this, we have that. That, we need to replace, since we're at all the cuts, we need to make forces. So that force will be Kj. This force will be dk. And then this one will be cd. I'm just putting them all in tension. And we know this height is 3 meters. That distance is 2 meters. So let's give it green. So with this, we need to go down 3 and over 2. And that would be the square root of, so I'm right over here, square root of 3 squared plus 4 squared. So that equals 9. Or not 3 squared and 4 squared. 3 squared plus 2 squared. So that's 9 plus 4, so that's the square root of 13. The hypotenuse for that common triangle. And that's just a ratio to figure out what percentage of each goes in the x and the y direction. I think that's it. So then we can just sum the moments about a point. Actually, I'm going to write in the ax and the ay. Ax equals 0, ay is 56.7 kilonewtons. So if now we can use any of our 3 equations of equilibrium. So we can sum the moments about a point or sum the forces in the x or the y direction. I'm going to sum the moments about a point that we have the most unknowns at. So sum of the moments about k equal to 0. And so sum the forces about, or the moments about k. So our point k. Then we have ax, which is just 0, so we won't worry about that. Ay will create a negative moment, so negative 56.7 kilonewtons, and then times that perpendicular distance, which would be 4 meters. And then the 20 kilonewton force will create a positive moment. So plus 20 kilonewtons times 2 meters. That 30 kilonewton force is along the same line as K, so there's no moment arm, so the moment would just equal 0. And then that CD will create a moment also. So plus CD times 3 meters. And that equals 0. So with this, we can solve for CD. So we get CD equal to 62.3 kilonewtons. And I got a positive number, so that means that I guessed it right, so it is in tension. So that's one of them that we need. We also need to we can also sum the forces in the y direction equal to 0. And so I'll just go around. So AY is 56.7, minus 20, minus 30, minus that y component of dk. So dk times 3 over the square root of 13 equals 0. So dk equals um, 8.0 kilonewtons. And we got positive also, so it is in tension. And then the last one is we can sum the forces in the x direction equals 0. We have AX, which is just 0, plus CD, which is at 62.3 kilonewtons, plus that x component of dk, so plus that 8.0 kilonewtons times 2 over the square root of 13, plus kj equals 0. So we get kj equals, and it's going to be a negative number. Let's see. We get 66.7, negative 66.7 kilonewtons. So kj equals, so we just guessed the direction wrong. So it's 66.7 kilonewtons, and it's actually in compression. So now we can go back up. So we need to find kj, kd, and cd. And we found kj, cd, and dk. So we're all set.